Okay, so now we're going to talk about the third type of conic section, which is going to be the hyperbola. So the hyperbola, basically, the geometric definition is just the set of points for which the absolute difference is from two fixed points, which is called a foci. So you can kind of think of the hyperbola as the opposite of the ellipse. So imagine that the ellipse is closing inside. Well, now the hyperbola is, imagine that it's going towards the outside. So here is one example of a hyperbola that's opening in the x direction. So these guys are also going to be my major axes. And actually what we're going to call them is we're going to call the transverse axis. So that's where the hyperbolas are located. So one of the things to know about this is, like, let's say this is going to be, what can I call this? I'm going to call this, well, it really depends on what the formula is going to be, but call it A. So it'll be negative A and then A. So then this will be B and negative B. So usually what happens with this hyperbola is that I typically draw a little box with the A and the B. So when we're graphing it, I typically like to draw this, because what's going to happen is that this hyperbola, so pretend that that box is it's symmetrical. So this hyperbola is going to have asymptotes along the diagonal. So imagine that those are asymptotes. I'll draw it a little better in a little bit. So you have asymptotes going off, and then these hyperbolas, or these curves, are getting closer and closer to the asymptotes. So let me draw it a little better. So this curve is getting closer and closer to the asymptotes themselves. Same thing on this direction. So on this direction, you have asymptotes, and you have the curve getting closer and closer to the asymptotes. So there's a couple of features that we have. We have asymptotes. We also have transverse axis. We also have foci. So that means that instead, the foci are actually going to be on the outsides. Okay, so this is like our C, our negative C and our C. So that means for any point on the hyperbola, the distance from one foci to the other foci is going to be constant no matter what we choose. So the distance, let's say this is D1 and D2, basically the difference between the distances is going to be constant. Okay, and with not that hard math, you can kind of see that it's also going to be equal to 2a, just how we had it before with the ellipse. So this is one that's kind of going off to the x-axis. You also have another type of hyperbola, and that type of hyperbola is now going kind of vertically. So if you think about this as now going to be your A, negative A, and then B, negative B, and B, then you definitely have these asymptotes. This box first, then we draw the equations of the asymptotes, and those are just going to be along the diagonals. And now the hyperbolas can also look upward, so they can open up and then can also open down. So you have these hyperbolas that kind of look like this. So now the only thing that I did is I swapped the A's and the B's together. So usually when you have a hyperbola that's open up to the sides, the equation for this will be x squared over a squared minus y squared over b squared equals 1. That will be the equation of the hyperbola. So basically you can think about it as a negative instead of a positive. So it's just like the equation of the ellipse, but now with the negative. And when you have it up and down, that means that they're opposite. Y squared is the one that's opposite, that's positive, and then the x value is the one that's negative. Okay, so this is when you have a hyperbola and it's opening up and down, that's basically what it's going to look like. So so again, the foci are going to be right here. This is going to be positive C. This is going to be negative C. So obviously we can find them as well as the equations of the asymptotes. So what are some of the formulas? So I wrote down here, kind of similar to how I did it with the previous ellipse. You can pause the video if you want and write it down. So basically, if you want a kind of like a horizontal hyperbola, so let me draw this in a different color. So if this was horizontal and this is vertical, these are the equations, which is basically what I did. The vertices are going to be wherever the transverse axis is, which is going to be plus or minus a for both. So that's wherever the branches the branches of the hyperbola are. The transverse axis is basically where the vertices are located. So this one's horizontal, the other one's vertical. The equations of the asymptotes, think about it as the rise over the run. So if you think about rise over run, remember that you're looking at the y divided by the x. So in this case, the y is going to be the b value and the x is going to be the a value. That's why we have b over a. And that kind of makes sense, right? Because you go up b units over a units. Here is opposite because now a is under y. So the rise is now going to be the a divided by the b. So that's just basically what we have. So that makes sense. You go up a over b units. And they're plus or minus because they're going off in two different directions. The foci, notice that the foci are a little different than they were with the ellipse. Now it's basically the Pythagorean theorem. So if you think of the Pythagorean theorem, that's basically what it is. The proof, however, for this one is a little bit complicated. So we're not going to prove it, but hopefully you can go ahead and take my word for it, I hope. So yeah, this is going to be the main equations that we're going to be using. So again, just like how we were doing the other types of conics, I'm not going to do the shifted conics until the next video. So what I want to do is I want to do a couple of examples using these, with the hyperbola. And it's basically the same thing that we've been doing. I mainly want to focus on graphing because I think the graphing part is the most crucial part. So let's do a couple of examples. So let's find the vertices. Let's find the foci and asymptotes of the hyperbola. Okay, and then after that we want to sketch. So, and this is going to be the equation 25y squared minus 9x squared equals 225. Okay, so the first thing that we want to do is put it in the form that we want it. So notice that there's no equaling to 1, so we got to divide it by 225 every single term. So when I do that, I'm going to get y squared divided by, that's going to give me a 9, minus x squared, that's going to give me a 25, and this is going to give me a 1. Okay, so now let's go ahead and sketch it, because I think sketching it always makes it a little bit easier to work with. So if you think about it, this is how I like to do it. So first, this is my a value, right? So this is 9. That means in the y direction, you're going to go up 3 units, because it's a square root. So this guy is a squared. It's going to be 3. So negative 3 and 3. So this guy must be the b squared. So the b squared is going to give me 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the way that I like to do this is I like to draw a box first. To draw this box that will kind of help me. And then after that, I'm going to, off in the diagonals, I'm just going to go ahead and draw my asymptotes. So my asymptotes are going to be somewhere in there. Okay, now we got to think about it. Is the hyperbola opening up and down or left and right? Now notice that the y is positive, so that means it's going up and down. Okay, so this guy's opening upward, and then this guy is opening down. Oops, okay, that didn't work. And then upward, and then opening downward. So this is the graph. So it's not so much about which one's bigger, it's more about which one's below, which one's positive. So we graphed it. So notice that here we don't even need any of these equations if we don't want to. We can just literally figure out what the equations of the asymptotes are going to be. So let's look at asymptotes. So the equations of the asymptotes is basically going to be the rise over the run. So if you think about it, you start at the origin, you go up 3 units, up 3 over 5. So y is going to be equal to plus or minus 3 over 5x. That's going to be the equation of the asymptotes. This is assuming that it's starting at the origin. Now, if you really want to use this formula, then you can do so. Notice that a in this case is going to be this square root of 9, which is 3, and divided by square root of 25, which is 5. So that would be the asymptotes. And now we want to figure out the foci. So the foci, in this case, is going to be c squared equals a squared plus b squared. So c squared, a squared in this case was at 9. The b squared was at 25. Okay, so that's going to give me 34. So then c is going to be equal to plus or minus square root of 34, which means that the square root of 34, the foci are going to be up here. Okay, so here's foci, and they're going to be on the outside. So that means the points are going to be 0, comma, plus or minus square root of 34. Or you can write 0, comma, positive square root of 34, or 0, comma, negative square root of 34. Now, the only thing that we're missing is just the vertices. So the vertices, remember that that's going to be where the branches are at. So the branches are here. So that's going to be 0, 3, and 0, negative 3. So the vertices will be at 0, 3, and 0, negative 3. So that's where that's going to be at. Okay, so to do these types of problems, they're actually not too terrible. Again, you can use the formulas if you really want to. I personally don't use any formulas. I just go ahead and just count whatever I have. So, but that's how you do these this hyperbola question. Do one more problem where you deal with the length of the transverse axis. So right before we continue, the length of the transverse axis is basically, let me go back up. So the length of the transverse axis, let me color it in red, is going to be the length of the branches, or the vertices. So this guy is going to be the length of the transverse axis, just like this guy is going to be the length of the transverse axis. So that and that is the transverse axis. So if you want to know the length of it, you basically are just doubling A. So it's kind of just like how we were finding the major axis for the ellipse, but now we have the transverse axis for the sorry, I'm trying to like for the hyperbola, and I have the formulas here as well. Okay, so let's do one more problem. So let's say we want to, you're given this, given 9x squared minus 16y squared equals 144. And what you want to do, you want to find vertices. You want to find the length of the transverse axis. And you want to find the asymptotes. Okay. So the first thing to kind of do is that notice that this equation is not in the way that we want it in. So 9x squared minus 16y squared equals 144. What we got to do is divide by this 144 first. Okay, so I'm going to divide by this 144. And then I'm going to go ahead and just simplify this. So you're going to have x squared, what is this, 16? And then y squared divided by 9 is equal to 1. Okay. Now, even though the problem didn't ask us to graph it, I'm still going to do it anyway because I feel like it's useful. So in the x direction, notice that you're moving 4 units over because this is going to be now my a squared because that's the guy that's positive. This is going to be my b squared. So that means a is going to be the square root of that, which is going to be 4. And then negative 4. And then in the y direction, it's going to be 3. 1, 2, 3. 1, 2, 3. So we're going to draw this box because it's a hyperbola. God. So now we're going to draw my asymptotes as well. And notice that since x was the one that's positive, then it's going to be in that direction. That's where my hyperbola is going to be. Okay. So then it kind of gives you a glimpse of the asymptotes themselves as well. So the equation of the asymptotes would be y is equal to, okay, so what's the rise over the run? So if I start at 0, I'm going to go over up 1, 2, 3 over 4. So it's plus or minus 3 over 4x. So you can use the formulas if you want. That's right above. That's completely fine also. And you'll see that it's b over a in this case. Then we want to find, what else do we want to find? We want to find the vertices. So if we want to find the vertices, that's pretty basic. You can see that that's just going to be 4, 0, and negative 4, 0. So you can write plus or minus 4, comma 0 if you want. Then you want to find the length of the transverse axis. So the length, notice that that's just going to be 2 times a. A in this case was 4, so it's 2 times 4, which gives me 8. And then finally, did I not want the foci? Well, I guess I didn't want the foci. Okay, well, let's just find the foci just for the heck of it. So you want to find the foci. That's going to be c squared equals a squared plus b squared. So c squared is going to stay a squared. That's just 16, and then plus 9 squared. Oh, no, just 9. So you're going to get c squared equals 25. So you can see that c is going to be equal to plus or minus 5. So since the value of c is going to be along the x-axis, then the point or the coordinate is going to be plus or minus 5, 0. Okay, so those are going to be my solutions.